Tension force. A box of mass M is suspended from the ceiling by two ropes at different angles θ1 and θ2 with respect to the horizontal. Draw a free body diagram for the box. Do not draw components of the forces on the diagram. B. Derive an expression for the forces acting in the x and y directions in terms of the mass, G, the tension force in each string, θ1 and θ2. C. Which tension force is greater? Justify your answer. Here's our free body diagram. We have mg acting down, then T2 along with rope 2 and T1 along rope T1. Now, they don't want you breaking it down into components yet for College Board. Just draw the three forces. Each rope exerts an upward tension force and gravity exerts a downward force. Derive an expression for the forces acting in the x and y directions. So here's our T1, here's our T2. We make a right triangle there by drawing an xy axis where the ropes connect to the mass. There's your x, here's your y axis. Resolve the tension forces into x and y components. The box is not moving, so the acceleration and the net force in both directions is 0. So this is going to be T1 cosine θ1, T1 sine θ1, then on the other side, it's very symmetric, T2 sine θ2 and T2 cosine θ2. The sum of the forces in the x direction is, considering positive to the right, sum of the forces is T2 cosine θ2 minus T1 cosine θ1, and that equals 0. There's no acceleration. The sum of the forces in the y direction is T1 sine θ1 and T2 sine θ2. There they are. And we have mg going down, so that's negative. And once again, the acceleration is 0. Which tension force is greater? Use the sum of the forces in the x direction. This way, we don't have to worry about the mg in the y direction. So we have T2 cosine θ2 is T1 cosine θ1. So T2 is going to be equal to T1 times cosine θ1 over cosine θ2. The picture shows that θ1 is greater than θ2, which implies cosine of θ1 is less than cosine of θ2. So your numerator is smaller than the denominator. So you'll have fractions like, 1/2, 5/6, etc. It will always be less than 1. So if this term is less than 1, when you multiply it by T1, you get a small number. You get T2 being smaller than T1. So T1 is smaller than T2, or another way of saying that, T1 is greater than T2. The more vertical the rope, the greater the tension.